Assalamu alaikum everyone. So yes, from here we will continue. We have ended till question number 14. Now let's start with question number 15, and we are actually doing organic MCQs. Now question number 15. One minute. An organic ion contains a carbon atom with a negative charge is called carbon anion. An organic ion containing carbon atom with a positive charge is called carbocation. It is same. For example, if you have a CH3 having a carbon with a negative charge is carbon anion, and a CH3 or any other alkyl group with a having a carbon with a positive charge is carbon cation. The reaction between aqueous sodium hydroxide and 1-bromobutane by SN2 mechanism. Okay, Abdullah, let me check. Okay. So what is the first step in the mechanism? If you recall, where we have a carbocation. So here they are saying carbon anion, which makes B wrong, because if you recall, there is either SN2. Actually, if you recall SN2, so in SN2 occurs with a primary one, as they have shown you 1-bromobutane, where there are 2 hydrogens, and let's suppose it's C3H7. So this carbon is partially positive and this bromine is negative. So nucleophile, whatever the nucleophile is, whether it's a cyanide ion or a hydroxide ion, it attacks this partial positive carbon, and as a result, heterolytic breaking occurs. So in D says it's homolytic breaking, which makes D wrong as well. Now we are left with A and C. Attack by a nucleophile on a carbon atom with a partial positive charge. So see, that is what taking place in the mechanism which I have drawn. So it can be correct, but let's assure whether C is correct or wrong. Heterolytic bond fusion followed by the attack of nucleophile on carbocation. So in 15, as I have told you in the lectures as well, that nucleophile attacks, and at the same time the bond is broken down heterolytically. But here they are saying that in C part, heterolytic bond fusion followed by attack by a nucleophile on carbocation. So C, the carbocation, it's not a carbocation, it's a partial positive carbon, which makes C wrong as well. Okay, so A is your answer in this case. I hope it's understandable to everyone, right? So this is the first step, and this is the second step. The nucleophile is attacking the carbon, which is actually if it is a C can be correct if instead this C, this one is a primary alkyl halide, right? Primary halogenoalkane. So if instead this primary halogenoalkane, if there is a tertiary halogenoalkane is there, then in that case, first tertiary halogenoalkane turns into a carbocation, and then the nucleophile attacks. So nucleophile is attacking on a carbocation, right? And the bond broken is a heterolytic breaking, due to which a carbocation is formed. So then the C would be correct. For this case, we have a primary halogenoalkane, so C is wrong. Okay. Yes, is this clear to everyone? Okay. Now question number 16. I think we have discussed this question. Compound X can be converted into compound Y in a single step. Okay. What could be the identity of compound X? Okay. So if you are saying that all are alkene, okay. So how do you figure out which compound is this? Which can be X. So first count the number of carbon atoms in a chain. 1, 2, 3, 4, 5, and 6 carbon atoms in a chain, and seventh one. 1, 2, 3, 4, 5, 6. Yes, 6 carbon atoms in a chain, and seventh one is in the side chain or the branch. Okay. So there are 7 carbon atoms, right? So in C and D, I can easily mark C and D wrong because there are 8 carbon atoms in them. Okay. Now, if you look second carbon, okay, let me do the numbering in this way, because when we are putting the name, the carbon number first is the one which is carboxylic acid. So 1, 2, 3, 4, 5, and 6, and seventh one is this. So the branch is on second carbon. Now look at A and B. If I break the A from here by oxidation, and I break the B from here by oxidation, so see, this convert into carboxylic acid in both the cases. So this carbon can be a carbon 1 which I have mentioned in Y. So then this could be a second carbon, and this could be a second carbon as well, right? So in B, the second carbon doesn't have a branch, and A second carbon have a branch, which makes us to figure out more quickly that A is our correct and B is not. So A will be your answer in this case. Okay. Is this clear? I marked B wrong as a, because when this double bond is, if the molecule is split in, is broken down from the double bond, carbon on the right would form carboxylic acid, and then the carbon which is next to carboxylic acid doesn't have a branch, but Y have a branch on the second, the carbon which is next to carboxylic acid. Make it wrong, and A is our correct answer. Is this clear to everyone? If you have any question, you can uh, ask me on WhatsApp or on chat. Okay, 1 minute. Okay, now question number 17. Which compound reacts with 2,4-dinitrophenyl hydrazine reagent but does not react with Tollens reagent? Okay. So, if you recall, which 2,4-diphenylhydrazine, aldehyde, and ketone both can react, but with tolerance reagent, only aldehyde would react and ketone would not react. Okay. So in A, there is a carboxylic acid. So our answer would be the structure which have an aldehyde. So A goes wrong. In B, there is an aldehyde, so this can be answer. In C, there is an aldehyde, so okay, 1 minute. They're asking me, okay, so with aldehyde tolerance reagent react and with ketone tolerance reagent does not react. And with 2,4-dinitrophenol hydrazine tolerance ketone react. So ketone is our correct is our actual answer. So here there is an aldehyde. That's why we marked them wrong, because these two can react with tolerance reagent. I marked D wrong as well, because D doesn't react with either 2,4-dinitrophenylhydrazine or tolerance reagent. Sorry. In A, carboxylic acid doesn't react with anything, but here we have a ketone. We have a ketone, right? So that ketone can react with 2,4-DNPH, but does not react with tolerance reagent. B, C, and D marked as wrong, and A is the correct answer. Okay, Dawood, your question is, sir, when double bond breaks, why does ketone form? Okay. Now question number 18. Structural isomerism and stereoisomerism should be considered when answering this question. The molecular formula of a compound is C5H12O. The compound X alkaline aqueous iodine. Okay. Can be dehydrated to form two alkenes only. Okay. So what they are talking about, compound X, compound X is C5H12O. It reacts with aqueous alkaline iodine. So first thing that you look over here, its general formula is CnH2n plus 2O, right? it can be an alcohol. And if it can be an alcohol and it is reacting with aqueous alkaline iodine, so from these two things, we can predict that this alcohol must have this structure, that CHOH is adjacent to CH3. Okay. And the other thing that they are saying that it can be dehydrated to form two alkenes only, not more than two alkenes. So if I will draw A, for example, okay, one thing, okay, all are 5 carbon atoms. So in the first one, two, three, and third carbon have a branch, then fourth, and then OH. Then 1, 2, 3, 4, 5, and third carbon have a OH. Then 1, 2, 3, second carbon have a CH3, third carbon have a OH, and CH3. Then we have 1, 2, 3, 4, 5, and second carbon have a OH. So these are the structures. Okay. So when I dehydrate this one, I'm going to get only one alkene. So A goes wrong. With this one, if the hydrogen is removed from the carbon which is on the right or carbon on the left, it doesn't matter. It is also an alkene, and we are getting only one product over here as well. So B goes wrong as well. Now, third case, we can get one product, this one, and then we can get another product, this one. So here I'm getting two products. If we look at the fourth one, that is the difference between the third one and the fourth one. Sorry. So one alkene, this would form, and there is an other alkene, this would form, but this can show cis and trans both. Okay. So here we are getting three products. which makes D wrong, and our correct answer would be C in this case. Okay. Now, question number 19. Which volumes of hydrogen measured under room condition is produced when 0.160 gram of methanol reacts with an excess of sodium? Okay. So what they are saying, we have a methanol CH3OH, and it is reacting with sodium. What products we will get? CH3O Na and hydrogen. To balance this equation, I have to put a half over here. Okay. So this would be my equation. Okay. Now, if there is a 1 mole of methanol, so what would be its mass? It's actually equal to R. So 1 carbon makes it 12, 4 hydrogen 16, and 1 oxygen 32. So 32 gram of methanol is producing half mole of hydrogen, and half mole of a hydrogen makes 12 decimeter cube volume, right? So if we have a 0.160 gram of hydrogen or methanol, then X volume would produce. Okay. So calculate the value of X. Can anybody calculate the value of X? Tell me the answer, please. Into 12 divided by 32. Yes. See, there is a half mole urea, half mole of 1 mole of hydrogen occupies 1 mole of any gas occupies 24 decimeter cube. So if there is a half mole of hydrogen, then half mole occupies half of the 24 decimeter cube, which is 12 decimeter cube. Okay. Zero point zero 0.06 decimeter cube. So that is 1 mole of a gas occupies 24 decimeter cube. And here we are getting half mole of a gas. So half mole of a gas occupies 12 decimeter cube. That's how I will take out this volume 12 decimeter cube. Okay. So the answer would be 0.06 decimeter cube, and here the answers in centimeter cube. So 0.06 times 1000 will give you centimeter cube. So 60 centimeter cube, which makes B, C, and D goes wrong, and A is your correct answer. Is this understandable? Yes, is this clear to everyone? Now, question number 20. Compound X produces a carboxylic acid when heated under reflux with acidified potassium dichromate. So it means that compound X can be an aldehyde or alcohol. Compound X does not react with sodium metal. So it's not alcohol, it's aldehyde only. Because with sodium metal, alcohol will react. Okay. What could be the identity of compound X? So alcohols and it's a ketone. So all goes wrong. And we are left with one propanol, which is an aldehyde. So A is our correct answer. Is this clear to everyone? Yes, is it clear to everyone? Now, question number 21. A reaction occurs when a sample of 1-chloropropane is heated under reflux with sodium hydroxide dissolved in ethanol. So it's an elimination. Remember, it's an elimination. And in elimination, it's a 1-chloropropane. So when elimination occurs, it will turn into propene. So here, these two goes wrong. These can be an answer. But here, the type of a reaction is wrong, which makes D wrong. And B is your correct answer. Now, question number 22. Ethane dioic acid has the formula. Okay. What is the formula of aluminum ethane dioate? So if you look, there are two hydrogens which are displaceable. So when it forms an anion, it becomes C2O4 2 negative, and aluminum have a 3 positive charge. So the formula would be Al2C2O4 taken thrice. Okay. So B, A, and C goes wrong. And D is your correct answer. Now, question number 23. Alcohols, aldehydes, and nitriles can each be converted into carboxylic acid. Which description of their conversion into carboxylic acid are correct? Okay, so let me recall you. Alcohols and aldehydes are oxidized to give you carboxylic acid, and nitriles are hydrolyzed to give you carboxylic acid. So for alcohol, the same way for aldehydes as well. For nitriles here, it is written oxidation in D part, which makes D wrong as well. So C is the correct answer. Is this clear? Now, question number 24. Just give me a minute, please. Question number 25. How many structural isomers with the molecular formula C4H10O give infrared absorptions both at approximately 1200 centimeter inverse and at approximately 3400 centimeter inverse? Okay. So first we have to look into it. For 3400 centimeter inverse, they can be an alcohol. And at 1200, okay, let me check 1 minute. Can anybody check and tell me for the 1200 if I am not mistaken? It is carbon-carbon double bond. Okay. So, and if you look at this formula, it is CnH2nO so if it's CnH2nO, then it can be an aldehyde, it can be a ketone, and it can be a compound having carbon-carbon double bond and OH. So if they are talking about the signals at 3400 centimeter inverse and 1200 centimeter inverse, then aldehyde and ketone would not be an option. And the compound which have both these two things, the carbon-carbon double bond and OH, then they can show these signals. So now we have to work on those compounds which can have these two groups, and along with these two groups, how many structural isomers were there. So the first one would be 1, 2, Okay, sorry, 1, 2, 3, 4, and here I have an OH and double bond over here. Okay, then OH. This can be a second answer. No, you don't have to memorize. Okay, you don't have to memorize it. These values will always be given. Then third isomer, fourth one, so here we are getting the 4 structural isomers of C4H10O, which have an alcohol and C double bond O both, which makes B correct answer. Now question number 25. Polyethylene and PVC are the examples of addition polymers. Which statements are correct? On combustion, PVC can produce carbon monoxide, carbon dioxide, and hydrogen chloride. Okay. So for this one, if we call A is 1, 2, and 3, B is 1 and 2, C is 2 and 3, and D is 1 only. Okay. So now, so this can be a correct statement. When polyethylene is buried in a landfill sites, it will not significantly biodegradable. Yes, this can also be a correct answer because polyethylenes are not biodegradable. The empirical formula of an addition polymer is same as that of the monomer. Yes, that is also correct. So A is your correct answer in this case because all of these 3 statements are correct. Again, we have these 3 statements. A can be 1, 2, and 3. B is 1 and 2. C is 2 and 3. And D is 1 only. When compound X gives a precipitate, organic compound X gives a precipitate when warmed with aqueous silver nitrate. Okay. This precipitate dissolves when concentrated aqueous ammonia is added. Okay. So in concentrated aqueous ammonia, both the precipitates of silver chloride and silver bromide are dissolved. And there is an iodomethylpropane. So silver iodide would form, which the silver iodide is not dissolved in either concentrated ammonia. It is completely not soluble. So 3 goes wrong. And if 3 is wrong, then 1 and 2 are correct. And in this case, B is your correct answer because this would give you silver bromide, which will dissolve in concentrated ammonia, and this will give you silver chloride, which also dissolve in concentrated ammonia. I hope is this understandable to everyone. So we will be keeping this class till here only, and we will do an yearly past paper, and that will be February March 23 in our next session, which will be before your exam on Tuesday. Okay, so see you everyone on Tuesday. Okay, take care everyone.